In this video, we are going to learn what we call trigonometric integrals. So there are three types to learn. So the first one is, let's say, sine mx, m to the power x, and then cosine n to the power x. That's the first type. Where mn and dx, where m and n are non-negative integers. So that means m and n can be 0 or any positive integer. So if they are not if they are negative integers, we probably use the substitution method to do it. So we can do some problems later. But right now we're going to focus on m and n are non-negative integers, 0 or positive integers. That's the first type. And the second type is the same thing but with secant and tan. So secant mx and tan nx. That's the second type because it's the powers. And the third type is sine cosine but with not powers but multiplication. So sine mx like that, and then cosine nx. So product rule. So we can use the products. So those are the three types that we're going to learn. So there are three types of integrals, but each type we're going to break into several other cases. So here, so the assumption is we're gonna do. So we assume that. So we can say where uh, m and n are m and n are non-negative integers. Non-negative integers. So that's the case we're gonna try integers. So for example, m and n can be 0 or 1, 2, 3 like that. So if they are negative, we do that separately. So any problem of this type has a especially the first two types, not the other type. The first two types have two special steps. So the first step is, so there are two steps for the first two. So so what are the major steps? That means any of these problems, the first step is you always have to factor a special term. So factor a term. So it's like that. Factor a term. Okay, the term depend on the problem, but remember you have to factor a term, special term, and then also we can use a special substitution and use a substitution. Use a substitution. Yeah. So those are the two types. So you have to factor a term and use a substitution. So that means, so what we're going to learn, how to pick that substitution, what kind of term you're going to factor. So those are the things that we're going to learn here. So let's go one by one. So we're going to start with the case 1. So the case 1. So in case 1, what we're going to do, we're going to do the sine cosine. So sine mx cosine nx when at least one of m or n is odd. So when at least one of m or n is odd. So that's the case. So if both are odd, that's still the same case, but we're gonna do it in a different way. We have to remember something in that case just to make the calculation easier. But let's do that as a separate problem. But right now, what we're gonna do it when at least one of m or n is odd. So let's try the steps. There are special steps. So the first one is you have to factor a term. Okay, so I'm just gonna write a factor a term, but it will be clear what is the factor that you're gonna pick. Okay, so so let's say let's write this one. So use the substitution. Let's say I'm gonna write in this one. This is not in the book. Okay, so u equal the other one. Okay, u equal the other one. What's the other one means? So that means if m is odd, if m odd, then we're going to pick u equal, if m is odd, we're going to pick the one on the other side, that means this one. So that means if m is odd, u equal cosine x. If n is odd, then u equal sine x. So that means if one is odd, pick the other one, not the odd one, the good one. Okay, so that's how you remember. So don't pick the odd one, pick the good one. So that's the substitution. That's how you pick the substitution. If it's something odd, pick the other one. And then we're gonna factor a term. So I'm just gonna write a factor a term because what you're gonna do is you're gonna factor the odd term, whatever the odd power, you're gonna factor. Okay, so factor a term. The odd one. Okay, so odd one. What we're gonna factor? We're gonna factor one of the odd one. Okay, odd one. Okay, whatever the odd one, we're gonna factor one of them. If the sine is odd, factor sine term. If the cosine is odd, factor a cosine term, like that. Okay, that's the second step. And the third step, what we can do, we have to use some of those identities. So we say we may use, okay, let's say use we can use we know that the sine squared theta equal 1 minus cosine squared theta, or cosine squared theta equal 1 minus sine squared theta. So you have to use one of them depending on the integral. And then also, you know, for larger powers, we also going to use what we call the Pascal triangle. So let's write that Pascal triangle. So this is also useful, Pascal triangle. So that is, so what's a Pascal triangle? We know that we're going to start with 1 and then we're going to start adding. So 1 1. Now what we're going to do, we're going to add the two upper ones. So 1, when you add 1 1, you get 2 and then 1. Now we're going to add, so this is 1, we're going to add 1 2, so you get 3 2 1 is 3 and then 1, so like that. So you're going to keep adding. So this is what we call the Pascal triangle. This is very useful when you want to find powers. So like for example, if you look at this line means 1 2 1. Where's 1 2 1 coming? So you can see, if you, let's say if you factor a minus b or a plus b, for example, I'm going to write a little special case here. So let's say you have a minus b. So when you square, the question is, what are the coefficients? So we know that when you have minus sign, you're going to alternatively change the sign. So that means you get a squared and then ab and then b squared. So those are the terms that you get. But you can see the coefficient. What are the coefficients? It says that the coefficient are 1 2 3. That's what this says. So that means 1 2 and 1. Those are the coefficients, 1 2 1, and then there's a sign. So this sign is negative, so we're going to put a negative sign here, and this is positive. So sign alternately change always. If it's a negative sign, you start with plus sign, plus minus plus, like that. If it's a plus sign here, everything is plus. Like for example, so if you have a plus b, what do you get? So it's a plus b squared is, we know that all positive, so it is 1 and then a squared and then plus 2, that's coming from the Pascal triangle, and then ab, and then again so we have a plus 1, that's again from the Pascal triangle, and then b squared. So the Pascal triangle is going to give you the coefficients 1 2 1, so like that. So let's look at another one. Let's say you wanna third power. That's a third power. This is for n equal 2. Okay, that's for 2. So this is n equal 1, this is n equal 2, this is n equal 3, like that. Okay, so and then we know that when n equal 1, that we already know, a plus b, when you have a plus b, you see the coefficients are 1 1. See 1 1. Okay, good. So how about 1 1 3 1 3 3 1 1 3 3 1? For example, let's do again a difficult one. Let's say you have a minus b cube. So what are the coefficients? It says that the coefficients are 1 3 3 1. So as we can do, we can start with a 1, and then yeah, I'm gonna write from red. So let's say 1, and then we have a3, that's a larger one, and then alternately change the sign, and then coefficient is 3, and then we have a squared b. So you can see the powers of a goes down, powers of b increases, and then so plus, minus, and then plus. So sign alternatively change if it is a negative sign. The coefficients are coming from here, so the next coefficient is also 3 according to this one, and then a goes down, that means a, b increases, so b squared, and then the alternate change sign, that means it's going to be negative. The coefficient is 1 according to this, and then you get a goes down, so I mean a is going to be 0, so you get b cubed. So that is the expansion of a minus b cubed. So you can just use this Pascal triangle to find any large power. So this will be useful when you do large powers. Okay, we can do at least one problem like that. Okay, so those are the kind of things that we need. So let's start doing problems. So again, so the case one, in the case one, what we do, we have m and n. So at least one of them is odd. So if at least one of them is odd, use the other one. Okay, so this is m is odd, use cosine. If n is odd, use sine. Okay, so you jump to the other one. That's how we remember. And that's not how the book explains, but this is like very easy, just done. So let's do some problems. So as the first example, let's look at this one. So let's say evaluate the integral cosine cube x dx. Now you can see that so this is a cosine odd power. That means so let's write. So the answer. So you can see here. Here n, so it doesn't matter whether n or m, just the other one, that's n equal 3, which is odd, so that means u is the other one, because this odd power for cosine, so that means what is the other one, means you become sine. Okay, you become sine x. So that's what the theory says, picks the other one. Okay, and then after that, this is simply a substitution problem. Okay, the theory only tells you what substitution you're going to pick, and then what you can do, you take the derivative of both sides. So that means du is simply take the derivative of sine, that means cosine x dx. So this tells you that what term you have to factor. That's the term you're going to factor. Okay, so you have to factor a cosine term. Okay, so you have to factor a cosine term. So let's do it. So that means these are the next steps. So you can see it's a cosine cube x dx. So the theory says that factor a cosine term. So what we can do, we can rewrite this one as cosine squared x. We can factor one cosine term for the du, because you can see this is simply du. Okay, so that's the reason why we're gonna factor that term. This is simply du. Now what we can do, we don't touch that, we leave it like that, and then the other term, that the cosine squared x term, you try to rewrite that using sine. For that, we can use the Pythagorean identity. We know that cosine squared means 1 minus sine squared x. See? So we can use the Pythagorean identity. We leave this one, so we don't do anything with this one, because that's simply the du. Now we can substitute. Okay, so yeah, so that's the step. So we're gonna we separate. Okay, so we separate one cosine term. Okay, separate one cosine term. So that's what we did here. We separate just one for the derivative. Okay, so that's the derivative part. Okay, now the rest is clear. We can substitute now, because we know that the sine x is u. So that means we can rewrite this one as 1 minus u squared. Cosine x dx is simply du, so it becomes du. So this is a really nice problem in the new variable, because this is du, so we substitute for that. Okay, now this integrate with respect to u. So if you integrate with respect to u, this becomes u minus u3 over 3 plus c, and we do not leave the answer like that, because you're going to substitute back, but we know that u equals sine x. So if you put sine back in, so this is simply going to be sine x minus, this is sine, so that means sine cube x over 3 plus c. So that is how you integrate cosine cube x, and you can see it's not that difficult. So try as an exercise, let's say cosine 5x, cosine fifth power x dx. So you can see it's very similar, and you can see the answer in the description. Okay, so let's try to do another problem. Okay, let's try to do another problem now with both sine and cosine. So example number two, both sine cosine. Let's say find or evaluate sine 7th power 7x cosine squared x dx. So according to theory, this is an odd power, so that means you have to pick the other one. Okay, pick the other one. So the solution, the answer, we can see m. It doesn't matter whether m or n. Okay, we don't worry about that too much. M, let's say something 7, which is odd. So that means we're gonna pick the other ones. That means u equal, the other one means cosine x. Okay. Now this is just a basic substitution problem after that. Okay, so this says that take the derivative, so du equal cosine means negative sine x dx. Now what we're gonna do, we have to factor out a sine term. Okay, we have to factor out a sine term, so we're gonna do that. Okay, so so let's do it. And also there's a negative sign, so you can multiply and divide by two negative signs, so like that. Okay, so let's do the next step. So what's gonna happen now? So sine 7x cosine squared x dx. So what we can do, we have to factor out one sine term for the derivative part, and then after you pull out one sine, you're gonna get sine 6. 6 you can write as a cube of a square, because in the 6 means 2 to the cube power, so we can write like that. So we can write this one as this, we're going to have a 6, so we can write 6 like sine squared x to the cube power. So the reason is because we know that the sine squared you can write as 1 minus cosine squared, then you can use a substitution. So that's the kind of idea. Okay, so we do that keeping that in mind, and we leave this one no change, cosine squared x, and then this is the term that we factor out. So we factor out this. Okay, so that is the first step. So you have a sixth power you can write as sine squared to the third, because when you have two powers like that, we know that we multiply the two powers. So this is equal to sine 6th. Okay, so this is simply equals to sine 6x. Okay, that's how we write it. And then how to get 7? Because we have the other one is right here. Okay, that's the other one. Now we know that this thing is simply negative du. Right? So just to avoid the negative sign, what we can do is we can put the negative sign outside and put the negative sign there. So that we can do. So now let's try the rest. So what's going to happen now? We're going to rewrite this one using the cosine, but we know that this one is simply by the Pythagorean identity. This is simply 1 minus cosine squared x to the cube power. This is cosine squared x, and then we just leave this one. Or what you can do is you can multiply inside outside by du, or put the d negative sign outside. So so this we can write, we just leave it like that. This is easy to understand. Okay, now what we're gonna do is we're gonna use the substitution here. So you can see after substitution, so this is 1 minus cosine means u, so this is u squared to the third power. Cosine means u, so this is u squared, and we know that the sin x dx is negative du, so you put the du here, negative sign outside. Okay, because this is simply negative du, put the negative sign outside. Okay, now this is where we can use the Pascal triangle. Remember, according to Pascal triangle, this is like a minus b cube term, so the coefficients are 1 3 3 1, so we can use that now. So this is simply negative. This is the Pascal triangle here. So you cube 1, so we can write it like that if you want. So it is 1 cube, 1 times 1 cube minus 3, and you can see 1 times the square of this term. Okay, so square of u. So this is so what are the terms we get? A3 and then a squared b. So b means here u squared, and then plus 3 u square this one. So I'm going to write this one because it's the first time we are doing it. So it is u squared squared. This is simply Pascal triangle, and then minus u squared to the cube power. So you can see these are the terms that we get from the Pascal triangle. I'm going to write it here for comparison. So what are the terms? A3 minus 3a squared b plus ab, no, plus 3 ab squared minus b3, and you can see in this case is a is equals to 1, this is 1, and then b, what is b? B is equal to u squared. Okay, b is equals to u squared, and once you plug in that, this is what you get. Perfect. And then we have u squared du. So let's simplify this again a little. So we have 1 minus 3u squared, and then 3u to the 4th power, and then we have minus u to the 6th power times u squared. So what we can do now, we're going to multiply through. We have that u squared term, so you're going to multiply through. So if you multiply through, what do you get? You're going to get negative. You're going to get u squared minus 3u to the 4th plus 3u to the 6th and minus u to the 8th du. Now you can see you can integrate now. Okay, so once you integrate now, and then you can substitute for that. So so let's do it. Okay, so I'm going to integrate term by term. So this is equals to, I'm going to rewrite the integral again just for comparison. So sine 7x cosine squared x dx. So it's a negative. So we're going to integrate term by term. So so again, what we have, so we had u squared minus 3u to the 4th plus 3u squared minus u to the 8th. That's what we had. Now what we're going to do, we're going to integrate term by term. So if you integrate term by term, you get u3 over 3 minus u3 over 5th u to the 5th plus 3 over 7 u to the 7 minus 19 u to the 9 plus c. And also you can multiply by the negative sign and then also substitute for u, because we know that u equal cosine x. So you put back in now, because u equal cosine x. So you put that back in, and also multiply by the negative sign. So you get negative 1/3 cosine cube x and positive 3/5 cosine 5th x and negative 3/7 cosine 7x and positive 19 cosine 9x plus c. Maybe this is the longest expression you ever wrote so far. You can do more, but you can see it's not that difficult, but there are certain steps that you need to remember. Good. So that's about that. Okay. So as an exercise, you can try this. So this is for exercise. So you can say exercise number 2, right? Exercise number 2. So let's do this. So let's say sine. Doesn't look like sine. Let's say sine 6th power cosine 5th dx. Okay. So try this. Okay, so let's do case 2. So we're gonna go to case number 2. So what's the case number 2? So far what we did was so you had sine and cosine one of them was odd. So what if both are odd? Okay, so you have sine mx cosine nx dx. So the question is, so when both m and n are odd, and you can see when you have and, that's a subcase of O. So you can see if both odd, then it's true that at least one of them is odd. So the question is which one you're going to pick. So the idea is we're going to pick the larger one in this case. Okay, so so let's write it. So so we're going to say use u equal the larger one. Larger one. Why we do that? You can see once you use the larger one, it's gonna take a lot of burden out. So let's just do an example. I'm gonna just write a few steps, but I will not completely finish the problem. So let's look at this problem. Okay, so let's say example number 3. Let's say let's look at this one. Let's say we have sine 9x cosine cube x dx. Cosine cube x dx. And you can see that according to theory, you can pick anything you like. But you can see this one is the larger one. So we're going to pick that one as u. So the reason is, see what's going to happen now. So what we can do, how we going to factor this. So as before, if because this is the one we're going to pick as u. So that means your substitution become u equals sine x. So pick the larger one. Okay, pick the larger one. That's what we're going to pick. Now what's going to happen, you can see we can write the integral like this. So so we don't do anything here, so we leave it sine 9x. But this one, because we know that once we take the derivative, du equal what? Du equal cosine x dx. So that means you have to pull a cosine term out. Okay, so that we can do. What we can do, we can leave cosine squared here and then pull one cosine out. Why we pull one cosine out? That for the derivative part, du. Now what we can do is the next step is, and you can see this cosine you can write as 1 minus sine squared. Okay, you can write this one as 1 minus sine squared because this is simply equals to 1 minus sine squared. So that means you can write the rest of the integral simply using sine. Okay, so yeah, let's write that. I'm going to write that step. So I'm going to write it on this side. So this is sine squared x. Let's erase this one for the moment. So now we can see what's going to happen now. So you can write this one as equal. So this is simply sine 9x, no change. This one you can write as 1 minus sine squared x. So this is cosine x dx. And you can see this simply u to the 9, 1 minus u squared. This is du. So this is simply a, so you can finish the rest of the problem right now because you know what's going to happen next. Okay, because you can plug in u now. Because u equals sine x. So this simply become du. And this one you can write using because this is simply u to the 9. And then this one is 1 minus u squared. Okay, so you can distribute. You can see this is a simple integral as we just did before. Okay, so that's what we do, because you can see in this case, since we pick the larger one, you leave the smaller one. So that means the transformation from sine to cosine is not that difficult. But if you did the other way, then what you get is you get sine to the 9 term. So that's going to be very difficult because you get sine to the 8 term. So that means you can write this one as sine squared the 4th power. Then you have the Pascal triangle of 4. That's a huge term. But to avoid that, we're going to pick the larger one in this case. Okay, so the secret is pick the larger one. Then you get a like really short integral. Good. So the next case. So far we talk about odd powers. So the next case is, what if both are even? Okay, so let's talk about that now. Case 3, case 3 both even. Okay, case 3, you can see both even. So we can again look at sine mx cosine nx dx when both when both m and n are even. So when both are even, you can see our argument failed. Okay, the argument, because they use the other one, doesn't work anymore. So that we're gonna do is, we have to use the double angle formula now. So we're gonna use the double angle formula. Okay, this is steps. So steps. So the goal is use a double angle formula. Use a double angle formula. Double angle formula. Okay, so what are the double angle formulas? So let's write them. So we know that one is sine square theta, which is equal 1 minus cosine 2 theta over 2. And we know that this cosine square theta, which is 1 plus cosine 2 theta over 2. So you can see sine is minus, cosine is plus. So those are the two that we're going to use. So you need to remember this one, okay? Because sometimes you have to use this multiple times when you have larger powers. Good. And also we remember some formulas from substitution method, or from the 4 formulas. So one is what is the integral of cosine. So we know that the cosine kx dx is simply 1 over k sine kx plus c, and then also we know sine kx dx, which is equal negative 1 over k cosine kx plus c. Okay, so you can use those two. The third one, for large powers, we also use the Pascal triangle. Okay, so Pascal triangle. So Pascal triangle might be useful. Okay, might be useful. Pascal triangle might be useful for large values of m o n, for large values of m or n. Okay, so that's the kind of idea. So we can use the double angle formula in this case, and also we can use some of the results from a substitution method. Okay, so let's look at a problem. So how about this one? So example, so let's say evaluate let's do this one. Let's say 0 to pi over 2 sine squared x dx, and you can see this is an even power, so that means we have to use a double angle formula. Okay, so that's what the theory says. Okay, it's an even power. So let's do the problem. So 0 to pi over 2 sine squared x dx. So I'm gonna write a half out. So this is the sine square theta. So that means according to the formula, so you can write this one as, you can rewrite this one using cosine 2x, because theta equal x now. So you can write this one as, I'm gonna write 1/2 outside. So it's gonna be 0 to pi over 2 1 minus cosine 2x. That's what the double angle formula says. So let's recall. So we know that sine square theta equal 1 minus cosine 2 theta over 2. So in this case theta equal x. That's exactly why you get that. Okay, so whatever the angle, double it. Okay, that's how we call double angle formula. So you can see you simply double this. Okay, you double it and put it there. Good. Now this is a simple problem. You can see you can integrate this one easily. So we can write 1/2 outside. So you integrate term by term. When you integrate 1, you get x. And this is cosine kx type of formula. We know that there's a cosine kx is a sine. So k equal 2 in this case. So that's the value of k. So k equal 2. That means 1 over k. That means 1 over 2 is a cosine. This becomes sine 2x. You can evaluate at pi over 2 and 0. So let's plug in the two values. So 1/2. So we're gonna plug in here first pi over 2. So it is sine. It's a x pi over 2 minus 1/2. Plug in pi over 2. So sine. When you plug in pi over 2, it becomes pi minus again 1/2. So let's plug in 0. So 0 minus 1/2 sine 0. We know that the sine 0 is 0. So this is gone. So that means you only get that. So that means, and also we know that sine pi over 2, which is also 0, because if you look at the sine graph, because it's very clear. So pi and 2 pi. So this is 0, pi, 2 pi. So this is something you have to remember. Sine graph and the cosine graph. Those are common things. So we can start here, negative, like that. So that is the 0, pi, 2 pi. That's the cosine. So you need to remember these two at least because these are very, very useful. So 1, and this is the negative 1. Okay, and then 1 again. So this we are 0. Okay. So according to that, this is 0. So that means you end up getting simply pi over 4 as the answer. Okay. So you can try this one. So this exercise number 3. So we have 0 to pi sine squared x dx, and you can see that's also actually if you do that you get pi over 2. So see whether you can show that, whether you get pi over 2. Good. So let's do a little large power. This is like sine squared. How about like power 4? So let's do it like this. So the next example, this is clear so far. So we use a double angle formula. Okay, so that's the major step. Use the double angle formula when you have even power. So the next example, so let's try, let's say find, how about cosine 4x dx, cosine 4x dx. So again use the double angle formula. So the answer again use cosine squared theta equal 1 plus cosine 2 theta over 2. Clear. 1 plus cosine 2 theta over 2 according to double angle formula. So let's try the steps. So it is cosine 4x dx. So we can write 4 as square square. So we can write sine, cosine squared x squared. Okay, so we write 4 like that. For 4 you can write as square square. If it is 6, we can write 2 to the cube like that. Okay, so if you have 4, we can write as x squared squared. If we have x to the 6th, we write x, always this is 2 and then cube. Okay, because then you can use the double angle formula here. That's the idea. Now yeah, so this one has to be 2. Okay, so this one inside has to be 2. Okay, that's the important, has to be 2. Or simply say it has to be square. Okay, has to be a square. then only you can use the formula. Okay, now we're going to substitute. So what's going to happen now, this you can write as using the double angle formula 1 plus cosine 2x, because the x, so double it, and then you have outside you have a 2, so you're going to put it there. Now we're going to distribute this. Okay, so you can distribute it, and then we have in the bottom you have a 2, so 1 is square it, that is going to 4. So we can write that outside just to make the calculation easy. So we write 1/4 outside, and then we have 1 plus cosine 2x squared. Now we can distribute that. So it is 1/4. So let's distribute that. We know that how to distribute this. So we can use the formula. So what is the formula? A plus b whole thing squared equal a squared 2ab plus b squared. We know that formula. So that's exactly what we can use here. So if you use that, you get first one is squared, twice the product, and the last one is squared. So that's a cosine is squared 2x dx. So you can see this is special term. For this one, we can use a double angle formula again. Okay, with the other one now you can integrate, so no problem. But we can use a double angle formula again for that. So if you use a double angle formula again, you get 1/4. We leave this one because now we know how to integrate these. These are easy to integrate. Here we can write this one as 1/2 1 plus cosine, you double the angle, it become 2x become 4x. That's what happened. Okay, so good dx. Okay, now you can see you can integrate everything. So we can write this one as now 1/4. So we have 1 and 1/2, so you have 3 halves, and then we have 2 cosine 2x, and also we have 1/4 cosine 4x dx. And you can see that you can just use the formula. Remember we had a formula, if we have cosine kx dx, this is simply equals to this is cosine, so 1 over k sine kx. So we can use that formula right now. Okay, so we can use that formula to integrate these two, this and that. Perfect. So let's do that, and then you should get this as the answer now. So that means finally after integrating you get the integral of cosine 4x dx is equals to 1/4. Outside we have 3 halves x plus, so we can divide 2 over 2 sine 2x plus, and then we have we already have 1/2, but we can divide by 1/4 sine 4x plus c. So if you simplify, you're going to get 3/8x plus you divide, so you get 1/4 sine 2x, and then here you get 1/32 sine 4x plus c. So that's the final answer for that. You can try this as an exercise. So see whether you can show this. So show that if you do the same with sine 4x dx, you should get so there will be only a simple sign change here. So you will get 3/8 x minus 1/4 sine 2x plus 132 sine 4x plus c. So you can see only difference is this is a plus sign, this is a minus sign. Everything else is exactly the same. Okay, so let's go to the next type. So this is case number 4. So now we done with sine cosine, and if we have a larger power, we pretty much do the same thing. And then you can also think of how to do sine squared x, cosine squared x. Then you have to substitute for both of them. Good. So how about this one? So this is case number 4. So now, so we're gonna go to the other type. So in case 4, what we're gonna do? We're gonna look at the secant tan. So we can do secant mx and tan nx dx. Okay. So the first one, what we're gonna do is when powers of secant is even. So when powers of secant is even. Okay, so we can talk about that first. So the secant has an even power. So this m is an even number. Okay, m is even. So if m is even, what we can do? So these are the steps. So we can do factor out secant squared. Okay, so factor out secant squared x. So that's very important. Okay, that's why I say you need the even power. You factor out secant squared and then use a substitution. So you can guess a substitution. So what's the substitution we're going to use? U equal, because the secant squared is the derivative of tangent. Okay, so u equal tan x. That's what we do. U equal tan x. And then it's depend on the rest. So we might use. So you're gonna say might. So we don't know. This identity secant squared theta equal 1 plus tan squared theta. Okay, so we also use that identity. Okay, so that's how you try to do a problem when secant has a even power. Okay, so let's do a problem like this. Example, evaluate. Evaluate. So let's say tan 6x secant 4x dx. Okay, tan 6x secant 4x dx. And you can see that secant has an even power. So this method applies for pretty much any powers of tangent. Okay, any powers of tangent, and secant has should have an even power. Okay, so secant should have a even power. Good. So let's say works for any power of tan, even like negative, square root, anything, it works. Okay, you're gonna see why. Okay, so the answer. So we're gonna say so use or let u equal tan x, and then du equals simply secant squared x dx. So you can see why this works now. So what we're going to do, we're going to factor out secant squared, and we're going to do the problem like this. So we have secant, we have tan 6x secant 4x dx. So we're going to leave tan 6x. We're going to factor out secant squared x dx, and we can leave that. That's for the derivative part, so we don't touch that. And the rest of the integral we can write using tangent. So that we can do. So that means this is tan 6x. We know the secant. Secant is 1 plus tan squared x, and we leave this one. Now what we can do, we can substitute. Okay, so let's substitute. So this is where we can use u equal tan x. If you use that, this is tan, so it's become u to the 6th. This is 1 plus u squared. Secant x dx is simply du. Okay, du. So this is du. Okay, now we know how to do this integral. So you can distribute first. So it becomes u to the 6th plus u to the 8th du. This is very easy to integrate. So this is u7 over 7 plus u9 over 9 plus c. And then we're going to substitute back from u. So this again we use here. So this become 1/7 tan 7x plus 1/9 tan 9x plus c. Okay, so that's how it works, and you can see that this method works for any power of tangent. Okay, any power of tangent and even power of secant. Okay, so again, so not. So you can see any power of tangent, any power of tangent, and even power of secant. Okay, so those are the cases that we, so any power of tangent and the even power of secant, because you can see that you can do this same trick for any problem like that. Even like you can say square root tan secant square. So try this problem. Okay, so how about this one? So you can see the exercise. Try tan x square root secant 4x dx. Okay, so you can see that it works. Good. Now the next type. So what type we were talking about here? Secant has a even power. Okay, secant has an even power. So the next one is we can talk about tan has a odd power, and also you can separate secant tan. Okay, so the next case, so you can say yeah, let's start it like that. So the next case, so the case number 5, we can look at a similar integral secant mx tan nx dx when power of tan is odd, when power of tan is odd. So power of tan is odd. So the steps are like this. So we're gonna let's say so use u equal secant x. U equal secant x. This says that du equal, what's the derivative of secant? Secant tan. So secant x tan x dx. So that means you have to separate secant tan. Okay. So the second step is separate or factor out. Okay, separate secant x tan x. Secant x tan x. And then rewrite the rest of the integral using secant. Okay. So again, might use tan squared x equal secant squared x minus 1. because this is simply going to be u squared minus 1. So rewrite the rest of the integral using secant. Okay, so rewrite the rest of the integral using secant(x). Okay, so that's the idea. Okay, so let's see how it works. So now what we do, we're gonna pick u equals secant(x) and then factor out its derivative. That's a derivative. So factor out derivative and then try to rewrite the rest of the integral using secant. Okay, so let's look at a problem. That's the best way to learn. So example. So let's say find. So we have tan 5 theta secant 7 theta d theta. Okay, something like that. Again, so you can see that tan has an even power, and you can easily factor secant tan term. Okay, so let's do that. So the answer. So we have you start with tan 5 theta secant 7 theta d theta. So what we did, we're going to separate the secant tan term. So if you do that, you get tan 4 theta secant 6 theta, and then we separate the secant theta tan theta d theta. We leave it for the derivative part. Okay, so that's the derivative part. So what we can do, we're going to pick u equal secant theta. Okay, so we pick u equals secant theta. So du equal secant theta tan theta and theta d theta. Okay, perfect. So that means we need to rewrite everything else using secant. So that means we're gonna say, we know that this one we can write as before tan squared tan squared theta squared, and then I'm gonna rewrite here, but you can also substitute directly here just to avoid extra writing. I'm just write this for completeness. Now we know that this is simply secant tan squared theta means secant squared theta minus 1 whole thing squared, and this is secant 6 theta secant theta tan theta d theta. Now we're gonna substitute. So if you substitute, this is gonna be u squared minus 1 squared u to the 6th, and this is simply du. So du. Perfect. Now we can distribute this first. So this is u to the 4th twice the product square, and then u to the 6th du. Distribute. If you distribute u to the 10 minus 2 u to the 8th plus u to the 6th du. This is an easy integral. So 1 over 11 u to the 11 minus 2 over 9 u to the 9 plus 1 over 7 u to the 7 plus c. Now what we're going to substitute secant theta, because we know that this is u equals secant theta. So we're going to substitute back. So that means 1 over 11 secant 11 theta minus 2 over 9 secant 9 theta plus 1 over 7 secant 7 theta plus c. So you can see it's a little long, but it's not that difficult. Okay, this is a major step here. You're gonna convert everything into u because of the because of these two. Okay, good. Now let's talk about so, and then you can try any problem like that when you can when you have a tan has a odd power, because tan should have odd power to do that, because once you pull one of the tan term, the rest is a even power of tan. Since this is the even power of tan, then you can use the identity uh, tan theta equal so what's the identity we use tan square theta equal secant square theta minus 1. For that, um, the rest of the part should be even power. Okay, that's why originally tan should have an odd power, because once you pull one tan out, the rest is even. So okay, so that's the reason why tan should have an odd power. Okay, so let's talk about some other special cases. Some of them we did even earlier when you try to do 4 formulas, but there are some other tricks as well. So let's talk about that now. So I'm going to call it like other formulas. So let's talk about other formulas. So other formula. One of the things that we talk about is we talk about how to integrate tangent, because that has a special format. So let's recall that. So tan x dx. How we did this one when you try to talk about the 4 formula trick. So we know that the tangent is, you can write this one as sine cosine, sine x cosine x dx, and you can see that, and then you can we know that the derivative of cosine is negative sine. So what we can do is we put the negative sign outside, negative sign inside, and now you can see that according to the 4 formula trick, because the top is the derivative, the bottom is the function, and top is simply the derivative. So we can just use natural log for that. So that means this is simply going to be negative. This is simply a natural log cosine x plus c, and then we know that the negative sign means you flip it over. So that means this is simply going to be ln secant x. Okay, because it's a flip over. The negative sign means you're gonna, if you bring it inside, it's gonna flip over. So that means the cosine you can write as a secant, because that's a power. So it's going to be whatever the function inside is a negative 1 power. So negative of cosine negative 1 power means secant. That's what happened. So I mean this can give a new formula. So what's the new formula? So you can use this as a formula. So that means if you integrate tangent x dx, you will get natural log secant x. Okay, so that's a formula that we can directly use. Integral of tangent is natural log secant x. Okay, the next one. Similarly, you can try cotangent x. Cotangent x dx. What's the cotangent means? Cotangent means cosine over sine. Okay, and but this case is easy because we know that the cosine is the derivative of sine. That means this is simply natural log sine x. So no much trouble. That means we have another formula. So that means if we integrate cotangent x dx, you get natural log sine x plus c. So that's the other formula. Perfect. So what else we have? So we talk about tan and cotangent, and then we also have another one, the secant. So how do the secant? So let's do that one. Number 3, the secant. So secant has a special way to do it. So this is something like some special tricks in mathematics. So we're going to multiply by a kind of fancy 1. Okay, so we have secant x, so we multiply by 1, but 1 you can write in a different way. So what we can do, we can write we're going to multiply top and bottom by secant x plus tan x. So we're going to multiply by secant x plus tan x, the top and the bottom, because that's simply 1. So this like you multiply by 1. That you can do, but it's a kind of special one. Now we can distribute the top. If you multiply through, you're gonna get secant so you get secant squared plus secant tan. I'm gonna write secant tan first for a reason. Doesn't matter, it's just a plus sign, and then secant squared. I just switch the order. It's a plus sign, so it doesn't matter. And in the bottom you have secant x plus tan x. Now you can see that the top is the derivative of the bottom function. Is that right? The bottom function is secant tan. What is the derivative of secant? Derivative of secant means secant tan. Derivative of tan means secant is square. So the top is the derivative. Okay, so that's very clear. Derivative of secant is secant tan. Derivative of tan is secant squared. So that means this is just a natural log function. That means this is simply going to be natural log secant plus tan x, secant x plus tan x. So this is going to be another formula, and this is also very, very useful. So we can write this new formula. So that means the integral of secant x dx is equals to natural log secant x plus tan x plus c. So that's a formula. And also you can use a similar trick for cosecant. So I'm going to give you the formula and see whether you can prove that using a similar argument. So so this is the formula. So for so actually this has two formulas. So the cosecant x dx is negative natural log cosecant x plus cotangent x plus c, or positive ln, you put the negative sign inside. So remember, it's easy to remember, it's a negative sign inside or negative sign outside. Okay, but when you say negative sign outside, both positive, when you put negative sign inside, um, yeah, so either put the negative sign outside or inside. Okay, so only in one place. Yeah, so so that's the other one. This is for cosecant. So there are two formulas. Good. So try to do this as an exercise. Okay, try to show these. So both. Okay, and you can email me the answer by Monday. Okay, so try to show them and email me the answer by Monday for extra credit. Okay, good. So that's about that. And then, so let's talk about some other special situations. So there are more. So these are all the formulas. There are 4 formulas here. You have a tan formula, cotangent formula, secant formula, and the cosecant formula. Cosecant has 2 formulas. Okay, there are 2. Now let's talk about some other like I should say further examples. So how about these? So let's try to this one. So further examples. You can see there are a lot of things to discuss. So further examples. Further examples. So we can try this one. So the next example. So how about this? So let's say find the integral of tan cube x dx. So it's only tan. So what we can do? So there are no secant term here. So there's no secant powers there. So what we're gonna do is we can use. So let's try to see how we can do this. We try to kind of try to bring it to one of the formulas that we already know. So the answer, we're going to use tan squared x equal secant squared x minus 1. To get a factor of secant squared x. So that's the kind of way to do it. So we try to get a factor of secant squared x. And how are we going to do it? So let's see. So tan 3x dx. So we can write this one as tan x and tan squared x. So we pull the tan squared x terms out. Now we're going to substitute here. So we know that the tan squared is secant squared x minus 1 dx. Now we're going to distribute. You can see once you distribute, you can write this on two different angles. So the first one is tan x secant squared x dx. This is just a substitution problem because secant is the derivative of tangent. So just by the formula, you know the answer for this one. And the next one, we're going to write this negative tan x dx. Now we know the answer for that. Tan is natural log secant. So that means we can write the answer now. So if you use the substitution method for the first one, so since this is derivative, you can just use the formula trick for that. So simply create tan just as x. So if this is x, it's x squared over 2. So exactly like that's tan squared over 2. Okay. Or simply use the substitution u equal tan x. Okay. So you can see that works. And for the other one, this is just the natural log secant x plus c. If you want, you can bring the negative sign inside again. That means you're going to flip over. So that means tan squared x over 2. This one looks like x over 2 plus ln cosine x. Okay, it's going to flip plus c. So you can write the answer like that. So what we do is you can just use the substitution method or just a formula trick. Okay, so this is the formula trick. It's a FF. Okay, formula trick, and you can just get the answer right there. Okay, and then this one we just derive the formula. Okay, so now how about this one? How about these some easy cases? So let's say oh, what if we have tan squared? So let's say next example, tan squared x. What we can do for tan squared x? You can use the same identity because we know that tan squared means secant squared x minus 1 from the Pythagorean identity. So we use the same formula. We know that the tan squared theta equal secant squared theta minus 1. And then you can integrate term by term. Secant squared means tan x, minus 1 means x plus c. So that's easy. And also, let's focus on these two. We know these formulas. The first one, we know secant secant x dx. We just prove that secant x dx is natural log secant plus tan secant x plus tan x, that we know. And also we know that the secant squared x dx, that is simply tan x. So the question is, how about this one? What if let's say let's go to the next power. So secant cube x dx. So what we did, so we did the first power we did, second power we did, now it's a cube, third power. So, and you can see that for this problem, any of the all method doesn't work for this problem. You can use any of the previous ones. Okay, so so for this problem you have to use the integration by parts. Okay, so this is a special situation. Need to use integration by parts. Okay, so and still to do that we have to like kind of rewrite this problem. So what we can do, so the answer, so we can kind of rearrange this problem first. So what we can do, we're going to pull a secant squared term, because once you have secant squared, we know that that's a derivative of tangent. So we're going to leave one term here. We're going to pull secant squared x dx. Now what we're going to do, we're going to pick this one as dv, because that's easy to integrate. This one we're going to pick as u. So that is the trick. So that means du in this case is derivative of secant, means secant tan. So secant x tan x, and the v is the integral of secant, which is tan x. Okay, so we have all four now. So we have du and v. So we can use the integration by parts formula to finish the rest of the problem. Good. So so let's do that. So we pick u equals secant x, so we have du, and we pick dv, so we have v. Okay, so we have all four. So let's finish the problem. So again, so we have secant cube x dx. So this is what we did was we pull one secant squared x term out, and then we have u equal secant x, dv equal secant tan, secant x tan x dx. Actually, I'm gonna read that right. I need like a little bit more space here. So u equal secant x, dv equal secant x, secant squared x dx. So du equal secant x dx, secant x tan x dx, and the v equal tan x. Okay, v equal tan x. Now we're gonna plug in. So so we have uv minus v du, uv minus v du. So that's the dv, and this is the u. So let's plug in uv. So we have uv means u equal secant, v equal tan. So this is secant x tan x uv minus v, v equal tan x du equal secant x tan x. So this is secant x tan x dx. Okay, this is simply dv. Now what we can do, we're going to multiply the tan. So tan times tan squared, so we can write this one as secant x tan x minus, so this is secant x tan squared x dx. And tan squared x, we can rewrite this using again the Pythagorean identity. So you can rewrite this one as secant x tan x minus secant x. So this is secant squared x minus 1 dx. Now what we can do, we can write this one as two different integrals. So this is secant x tan x minus, this is secant cube x dx minus minus plus secant x dx. So secant cube you're going to bring to the other side. This one we already know. If you bring this one to the other side, we have 2 of secant cube x dx. This one is secant x tan x minus, on the plus, we know the secant x dx, the derivative of secant is natural log secant x plus tan x plus c, I'm going to c prime. Now what we can do, we can divide both sides by 2. So if you divide both sides by 2, you get secant cube x dx equal 1/2 secant x tan x plus 1/2 natural log secant x plus tan x plus c half over 2, which I'm going to call c. So you can see this is like a really long problem, but unfortunately this is the only way to do that problem. Okay, so you have to use integration by parts, and then we pretty much use like all the things that we learn. Okay, so we use the trigonometric identity, and then we factor out secant squared term, and then at the end we also use the integral of secant. Okay, so remember, like, this is a special problem. So if you get secant squared x, secant cube x to integrate, this is the way to do that problem. So unfortunately there's no other shortcut for this problem. Okay, and if you can find a shortcut method, like some nice easy way to do it, you can be world famous. So see whether you can find something like that. Okay, so that's about that. And then now we're gonna go to the last topic of this one, the last type. What's the last type is product formulas, sine product and cosine product. So let's talk about that, and that's the end. Okay, so let's talk about that as the product formulas. Okay, so this is case number 6. So case 6. The product formulas. So that means we can integrate these kind of problems. We can integrate sine mx cosine nx dx. You can see now it's a product, and then we're gonna do sine mx and also sine nx. So both sine nx dx, and c we're gonna do cosine mx cosine nx dx. These 3 types. So sine cosine, and then we have so one is sine cosine, and then sine and then cosine. So those are the 3 types. So what we can do, we can use the product identities. So we use these we use following identities. Okay, we use so let's say sine A cosine B equal 1/2 sine A minus B plus sine A plus B. Okay, so if we have sine cosine, we use both sine. Okay, we use both sine with a minus sign. If we have same type, for example sine A sine B, then these are both cosine. So we have cosine A minus B, and the minus cosine A plus B. And if we have cosine A cosine B, both cosine, then we have cosine A minus B plus cosine A plus B. So you can see, so there are some patterns to remember. You can see these are all a minus b terms. These are all a plus b terms. And then when both are the same type, you can see they are cosine. Okay, the formula, you have all cosine. If they are different types, like sine cosine, you can see one is sine, one is cosine, you have both, one is both sine. Okay, so there's a few things to remember. So everything is first line all a minus b, second line is all a plus b. If the same type, sine, same type, they are cosine. If they are opposite sign, both sine. Okay, and then when it's sine, it's a minus sign in the second one. When both cosine, they are plus sign. Okay, so yeah, so this is a kind of identity. But what's gonna happen if you're gonna use something like that in the exam? Probably we might give you this formula. Okay, because yeah, because you have a lot of things to remember. But if you remember, it's a good thing. So let's try to just one example from this. Okay, that's the last one. So how about this one? So the example, so let's say evaluate sine 4x cosine 5x dx. Now you can see this is m, that is n, so you just need to plug in this first formula. So the answer, so you can see this is a simple problem if you remember the formula. So it's a sine 4x cosine 5x dx, which is equal the integral half. So let's plug in. So it is sine. So I can call this is a and that is b. Okay, in the formula. So if you do that, so it is a minus b. That means 4x minus 5x, and this is a sine cos. So I'm going to say plus sine ax plus bx. So 4x plus 5x dx. Now we can simplify inside, so it is 1/2. You can pull it out. So we have from the first one you get sine minus x, and then plus sine 9x. So that's what you get. So this is very easy to integrate. So in this, for the first one, k is -1, so that means 1/2. You can pull the negative sign if you want. That's another way to do it. So negatives, because sine is odd function, you don't have to do that, but it looks good. Now we can use the standard formula. That means so negative sign means integral of negative sine x, that means cosine x, and then this is sine, that means negative cosine, so it's a negative 1/18 cosine 9x plus c. Okay, so that's the answer. So so we use the sine one here. So we know that sine kx dx equal negative 1/k cosine kx plus c, and we also have cosine kx dx equal 1/k sine kx plus c. Okay, so this is the end of how to do trigonometric integrals. Okay, so you can try this one. So integrate, let's say sine 6x and then sine 4x dx. Okay, so that's the end of trig integrals.